Hi everybody. This week we're going to work on cartographic excellence. You're going to get a chance to work with NetCDF data again. This is that network common data form for storing multidimensional files. You can mine them to display smaller subsets of data like temperature, wind speed, wind direction, humidity, air pressure, etc. And usually over time, and then they can be aggregated to different levels. It's a really common file format used by climate scientists and by the atmosphere and oceanography communities, and they're proprietary, so they can be used by different software and operating systems. So this week, what I want you to focus on is getting comfortable converting NetCDF files. You're going to create a professional map comparing two global maps in a layout form. You're going to be looking at the change in historic temperature. You've already worked with projected data, projected climate data, but the data from this week is historic data. And I want you to compare two different time periods against a baseline. So you're going to be calculating your own anomaly data using time periods that you set up. The bulk of the work is going to be focusing on symbology and creating a professional and efficient legend, one legend that works for both map frames. And hopefully the introduction to symbology that you got last week will come in very handy this week. All right, so this is the kind of map you're going to be starting with. This is a temperature anomaly map. You're going to pull your data from the NASA GISS website. I'll show you that in just a second. But you can see here, this is an annual from December to November average from 2020. And what they've done is they've subtracted the average for this 30-year period, 1881 to 1910. So this is the earliest record that NASA has for temperature is 1881. The 30-year time period gives us a nice climate snapshot versus a weather snapshot. So what we're displaying here are the changes in temperature across the globe from this 30-year period averaged against this annual set of temperatures. And so you can see here that in some places we're seeing increases up to 6.9 degrees Celsius. This is the average for the whole globe. So between these two time periods, we're mapping a 1.26 degrees Celsius increase globally. Okay, so I'll show you how to download that data in just a second. The important thing to know about making this map is that this climate data that you're going to be presenting doesn't explain itself well. The idea of a temperature anomaly map isn't clear to most people. So I want you to practice using annotations, labels, titles, whatever kind of text that you need to explain clearly what's being visualized. I want you to assume that the audience has just stumbled across your map. They don't have the background of the assignment. It's not me. Keep your text hierarchy in mind when adding annotations or text boxes to a map. And make sure you don't use paragraphs of information. No one's going to read that. And then make sure you're explaining exactly what the time periods are that you're working with. Let's go take a look at the NASA GISS website, and I'll show you what I mean. So I just typed NASA GISS into Google and then clicked on data sets, and it brings you to this page here. We're going to be pulling data from the global maps. And here's how the data gets set up. You can leave the data sources the same. These are the models, improving these models all the time. But we're going to use these land and sea surface temperature models. We want map type anomaly, not trend. The mean period, this is something that you can change. So you could pull data quarterly, which doesn't make a whole lot of sense because weather doesn't really care about quarters, but it might care about meteorological seasons. So winter, spring, summer, fall, or the full year. And then you can run the year from January to December or November to October. This is what you need to just make sure you're keeping track of. I do recommend 30-year time periods, but if you don't want to do that, you might want to be consistent. The map I showed you was a pretty good example of inconsistency. It was a 30-year time period compared to a 1-year time period. And that's really comparing oranges to apples. So here we can just type in our base periods. I'll use the base period of 1900 to 1929. This is going to be our baseline time period. Then you're going to run this tool twice. You're going to generate two maps. I want you to pick two different time periods. So one of them might be, so the 30-year period, 1950 to 1979, against the average for the baseline period. And you can leave these as they are. We'll make the map, and then you'll see this change down here. It takes just a second. So for April, this 30-year period compared to April of 1900 to 1929, we're separating these two, the average of these two 30-year periods. Globally, between those two time periods, we've seen a 0.27 degrees Celsius increase in temperature, and then the temperature changes are distributed globally like this. Let's try running it not for a month, but let's try running it for the meteorological year. I'm going to use the time periods, our baseline 1900 to 1929 and our earlier time period of 1950 to 1979. Okay. So here's our annual, December through November for the time period here, 30, and then we are subtracting the 30-year average for this earlier time period. We're seeing a global increase of 0.28 degrees Celsius, and this is the way the temperature changes are distributed across the globe. Let's change this now to 1982. I'm having trouble with math, apparently. We're going to use the same baseline period. And I think you'll see this number go up. And the map has changed quite a bit. So what we're doing here is we've got the same baseline 30-year period, but we're averaging this later 30-year period and subtracting this earlier one. And we're getting a global increase of 0.9 degrees Celsius. And you can see the map has changed drastically. The spatial distribution of temperature changes are almost all positive. It looks like there's a couple pockets of no change, and then the gray is no data. So you are welcome to use a 10-year period if you'd like to. It's a little bit less reliable. It's getting closer to weather instead of climate, but that's fine. Again, as long as you're clear in your map about what you're presenting. Okay, so run this tool twice. Pick a baseline period. Keep that the same. This should be an early period of time, right? And then two later time periods that you're going to compare against. Because what I want to see is this map compared to the one that we just had up. And what we're going to show is that temperatures are increasing globally over time. Okay. That's that. Let's head back to our PowerPoint. I just want to show you a couple of examples. Here are a couple of examples. So here we're showing the change over time. We've called out our annual mean baseline period and then the two later time periods. Temperature anomaly, come up with a better way of saying that. Get your units right with the values perhaps. This map is close in that in this later time period, we have a higher difference. So we have more warming from this time period to our baseline period. But the highest value is being drawn with the darkest red on this color ramp, and that's kind of a problem. So 3.5 degrees of warming should be, down in the orange, and so that the red can actually equal 5 or 4.5. So this is not a correct way to show this data. Also, by using yellow as the divergent point in the color ramp, because yellow is warm, we're imparting bias. Avoid that if you can. A student produced this map a couple years ago. I thought it was pretty incredible. What they compared was their lifetime against their grandparents or their parents' lifetime. I don't remember the exact details, but I thought they did a really nice job of creating a super clean legend. It doesn't need a lot of detail, and it's correctly displaying the temperatures so that we've got the warmest warms down here in the later time period. And we don't see those same deep reds in the earlier map. I think including the global average is a really cool move. It's extra information that is really handy. And then the annotations, notice the different text sizes and the font sizes. This is really nicely done. All right, that's it. This is a fun assignment. The devil is in the details. Focus on legends, focus on the nuances of symbology, and really take your time this week dialing in those details.